Okay, so today, our concept today is going to be inverse functions, okay? Inverse functions, all right? So, an inverse relation. So for us, we just want to say that any point x, y can be changed to a point yx, and this would be our inverse, okay? So we take any point, xy, okay? Which could be a point, say 2, 3. Its inverse becomes 3, 2. It's that easy. You just switch the points. Okay? Yeah, I gave you two sets of... So now, some things are functions and some things aren't. So we talked the other day about whether it's a function, whether it would, it passes that vertical line test, right? So an inverse function means it must pass the vertical line test, okay? So let me show you an example, okay? Let me show you an example. Okay? If we have a point at, let's take a point at 3, 1. Okay, here's my point at 3, 1, right? So here's my example. I got a point at 3, 1, right? Its inverse point would be at, its inverse, it's just going to be at the point 1, 3. Okay? Now, if we have to do a line, let's say we've got f of x equals 2x minus 4, okay? Write that down. If we have to do a line, we can go, there's two ways to do it. We could graph our line, which we will, graph our line, and then we can get individual points on our line, switch all those points, and graph the reverse points. So you get your line out, okay? Another way to do it is to switch all of the points all at once. All the points all at once. Well, there's an infinite amount of points. The way you switch all the points all at once is you take the x variable and the y variable. The x variable represents all of the x's. The y variable represents all of y's. And if you switch just the x and y, you've switched all of the points, okay? So I'm going to show you both ways, okay? So, step one, it says set y equal to f of x. So f of x kind of bothers a lot of kids, but keep in mind, I keep saying, y and f of x are the same thing, okay? They really are. So let's just, if you don't like f of x, just change it to y. Y equals 2x minus 4, okay? If you don't like f of x, just change it to y. Same thing. In this class, it's the same thing. Eventually, when we get to pre-calculus, it will mean something different. But you guys don't need to worry about that, okay? So then, step one, it says set y equal to f of x. We did that. And then step two, switch x and y. When I switch, watch, when I switch the x and y, I have switched all of the points. I haven't just gone from 3, 1 to 1, 3, right? When I've switched the x and the y, I've switched every single possible point they have, right? Which is a whole bunch because it's a line, right? Now it says solve for y, okay? So if I'm going to solve for y, here's y, right? Solve for y, I got to get y by itself, so let's go plus 4, right? When I have an x plus 4 equals 2y, right? Divide by 2, divide by 2. Am I going too fast? Okay, so it says solve for y, so plus 4, divide by 2, and now I can make this 1/2 x plus 2 equals y. Okay, how am I doing? Now, I want you to use the correct symbol. I'm not going to know this is an inverse until you tell me. So when you use this symbol, f of negative 1 of x, okay? Let me write that, okay? I want to highlight that, okay? That means it's the inverse, okay? So 1/2 x plus 2 equals that. I like f of x first, so I'm just going to say, okay, well, f inverse of x is equal to 1/2 x plus 2, all right? So, this is my original graph. This is its inverse. This is the original function. This is its inverse function. Okay, I'm going to keep teaching. Okay, if you're a little confused, bear with me. Let me keep going through this. Okay, there's plenty of notes to keep going through. Right? Okay, turn the page. Yeah, I sure can. Bijou that way. That way. There you go. Yep. Okay, you guys ready to turn the page? I'll wait for Bijou. Yeah, you guys slow me down. If I get going too fast, please slow me down. I don't want to go too fast. I'm trying to pace with you, but you know, if I get going too fast, you need to tell me, okay? Turn the page. All right, now, here we go. So, here we go. What do you notice? I've got x's of 0, 2, and then the inverse. This must be the inverse. What do you notice between the first chart and the second chart? What do you notice? What do you notice? Have they switched?
Yep.
So if these are the x's and these are the y's, because remember f of x is y, right? These are the y's, right? If you like y better, right? Then they've switched, right? So that means that this is the inverse because I took all my points, switched them. Took my points, switched them. Took my points, switched them. I switched my points all the way around so that this would be the inverse of this. Okay? Pretty easy. Just take my xy and switch around and make it a yx. Thumbs up so far? Okay. All right. So, use the coordinate plane below to plot two sets of points. So first, let's go back to what I just did on the prior page. I had a y equals a 2x. Was it minus 4? I think so. Yeah, minus 4, right? Y equals 2x minus 4. Let's try and graph that, okay? So, I'm going to go down to negative 4. So I'm trying negative 3, negative 4, right? So I'm going to graph this. I'm going to go down to negative 4. I'm going to go up 2 over 1, 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 right? Guys, you know how to graph a line, right? Start at negative 4, right? Up 2 over 1, up 2 over 1, okay? And then I'm going to draw that line in, okay? Okay. We know, and I'm going to show you another way to do an inverse line. I think this is the long way, but it's the easy way. I'll say it again. I'm going to teach you the long way, but the easy way. I'm going to teach you the way that takes more work, but it's easier to understand. Every one of these points, here's a point at 0, negative 4. Here's a point at 1, negative 2. Here's a point at 2, 0. Here's a point at 3, 2. Here's a point at 1, 2, 3, 4, 4. And here's a point at 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So I've got my 5, 6, right? Everybody got that? So if I want its inverse of this line, all I have to do is just switch the points, right? Does that make sense? So instead of 0, negative 4, I'd have a negative 4, 0. 1, 2, 3, 4, negative 4, 0. I just switch this point. 1, negative 2 becomes a negative 2, 1. Negative 2, 1 is right there. 2, 0 becomes a 0, 2. Starting to see a line. 3, 2 becomes a 2, 3, right? Starting to see a line. 4, 4 becomes a 4, 4, right? 5, 6 becomes a 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. There's my inverse. So we're going to say this is f inverse of x. How am I doing? So all I did is I took every single one of these points on my line, I switched them, right? Switched it, and I went to negative 2, 1, right? Switched it, I went to 0, 2, okay? I just switched it, and I was able to draw a line. That's my inverse line. That's my opposite, right? Just switch the points. Now, if I take a look at this pink line, what's the equation? Well, that's easy. We gotta know how to do that. So the equation B equals, let's see, it looks like it's up 1 over 2, right? Up 1 over 2. So it's a 1 over 2x plus 2, right? Right? Up 1 over 2, right? Starts at 2. There's my inverse equation, okay? Now, Go ahead and write that down. I'm going to flip the page back for just for a second, okay? Ready? Flip the page back. I already had that, didn't I? So there's two ways to get this answer. It's up to you. One way, this way I liked it. I switched the variables and solved, okay? That worked for me, okay? If you aren't good at manipulating algebra, okay, if you're not, then you could do it the long way. And the long way, which works, is take all the points and switch all the points. That works also, right? So there's two ways to do it. One is to switch the variables. That's the way I like to do it because it's faster. Or the other is point by point by point, switch the points and graph, okay? All right, let's look at the other sheet I passed out to you, okay? All right, let's look at the other sheet. All right. So, here's my question 1. Here's my points. Let's find its inverse. Okay, it's inverse. Okay, so how are you going to find the inverse of all these points? Yeah, Michael's right. We're going to switch them, right? Why don't you do that? Do that real quick. Take like a minute. It should only take a minute, agree? And just get the inverse of these points. Just the inverse of the points. So Michael said just switch them, right? Totally agree. So take a minute. Hey, Sush, you with me? Okay, so I'm just going to go -1, 1, right? There's the first one. Easy, right? Do the next one, right? 5, 2, right? All we're doing is switching the y's with the x. Easy lesson today, it really is. -2, 4, right? 8, 6, and 9, 8. Okay? Thumbs up. If you're right here and you get this, we're in a good spot, okay? Thumbs up, everybody good? Just all we're doing is switching x's and y's. Piece cake, right? Okay, now, how about this chart? Input. Cooper used the word input like last semester, or last quarter. I was pretty impressed. I like that word. Input, those are your x's, right? Input, output, those are your y's. So how are you going to do the inverse? Yeah, Michael's right. Just switch them. So go ahead and fill out the chart, right? Fill out the chart. Do that real quick. Fill out the chart. Okay? So we're just going to switch them. The inputs, which are the x's, and the outputs are the y's, we switch them and make the output become the inputs. Okay? So we should have 4, 2, 2, 5, 3, right? -3, -1, 0, 1, 3. Okay? How am I doing? Now, you ready? This is a function. This is not a function. Oh, what are you talking about, Mr. Davies? This is not a function.
Oh yeah, there's 2 2s.
This is good, okay? This is not a function. Okay? So if you buy 2 shirts, you with me? Or let's go lattes. If I go to Starbucks and I buy 2 lattes, they're going to say, oh, it's -$1. Oh, it's $0. My 2 lattes are going to cost me 2 different prices, right? 2 lattes is going to cost me 1 price, right? This is not a function, which means, you ready? This does not have an inverse. Does that make sense why it doesn't have an inverse? Okay, no inverse. Because its inverse is not a function. Okay, all right. How about number 3? It's not a function. Because I'm going to go and buy 4 lattes, and it's going to cost me $3, or I get it for free. Or it's going to cost me $3, or it's going to be free. I know which one I'm going to choose, but you can't have 2 prices, right? If you're going to buy 3 lattes, it's going to be 1 price. So this one is not a function. So if it's not a function, guess what? No inverse. All right? You guys agree with that? All right. Do you have graph paper? Do you have graph paper? Okay. Okay. Do you have graph paper? Okay. If you need graph paper, grab some graph paper, okay? Got graph paper up here. You need graph paper, okay? All right. Yeah, it's still recording, right? Yeah. Okay. Y equals x plus 3, right?
Right.
Okay, example 4 says solve for y, okay? So first of all, so when the output is 3, right? When the output is 3, we'd put the 3 in for the y, correct? Does that make sense? So we have 3 equals x plus 3. Solve for x. Tough. minus 3 minus 3, x equals 0, right? Five. Output's 3. This is y equals 3x minus 2. Remember, f of x and y are the same thing. You guys good with that? See, f of x, if that freaks you out, just write y, okay? So the output would be the y, right? So 3 is equal to a 3x minus 2. Right? Solve for x. Plus 2, plus 2. We're going to have 5 equals 3x, right? Divide by 3, and we get 5/3. Or 1 2/3. I'm okay with 5/3, I really am. 5/3 is a great answer. If you want to change it to 1 2/3, that'll work for me. Or if you want to change it to 1.6666666, you can put that too. But 5/3, cool, right? Okay, 6. F of x. Y the same thing, right? If the output is 3, then put the 3 in for the y, right? Okay, how am I doing? I'm not going too fast? Okay. Minus 6, minus 6. Oops, that's a bad looking 6. Negative 3 equals 3/4 x, right? Now, a lot of kids have a hard time with fractions. I'm going to do it the Landon way. This is the way Landon likes to do it because Landon's like, Dad, I don't do math. Yes, you do, Landon. No, Dad, I don't do math. But he does do math, right? So, with a fraction, see this little line right here? Come on, you guys. What's this little line mean in math? Divide. And when you solve equations, you do the opposite, right? What's the opposite of divide by 4? Sure, so let's multiply by 4. Multiply by 4, right? And then the 4's will cancel, right? So, we're going to now have a negative 12 equals 3x, and it's really easy. What? Divide by 3, right? And I get x equals negative 4. Now you could do it two other ways. You could divide by 3/4, or you could divide by 0.75, right? But I just did the Landon way. Landon likes doing it this way because it says easier, okay? Turn page. All right. Okay. Let's graph, okay? And I probably am only going to get time to do maybe a couple of these, but let's see what we can do, okay? So first of all, 4x, how do I graph this? Y equals 4x. How do I graph this? Yep, start at 0, right? Up 4, over 1, down 4, back 1, right? Here's my line. Pretty good on that? Okay, now, the inverse. Two ways. One, and if you don't like the way I'm going to do it, because I'm going to do it the algebraic way. One is to switch x and y and solve for y. That's the way I'm going to do it. If you don't like that way, figure out all the points are and switch the points. You can do it both ways, so I can show you both ways. Because I don't care which way you do it as long as you get it right. Me, personally, when I do these, I've got y equals 4x, and I switch it. I go, okay, well, x equals 4y, right? This is the way I do it. I switch, right? Do my little switch. Right? This is the way I like to do, okay? Then divide by 4, so I get x over 4 equals y, right? This is the way I like to do it. If you don't like doing it this way, there's another way, which I'm going to show you in a second, okay? So it's like start at 0, and that's like a 1/4, so I go up 1 over 4. Here's my inverse equation and my inverse line. Okay, got it? Now, what's the other way to do it? What's the other way to do it? Take the points. Take the points. The other way to get this pink line is take the points. I got a point at 1, 4, don't I? I got a point at 1, 4. So if I've got a point at 1, 4, if I switch 1, 4, what do I get? 4, 1. Ah, there it is, right? I got a point at negative 1, negative 4. If I switch that, what do I get? Negative 4, negative 1. See how that works? I don't care which method you like. Personally, for me, this is a lot faster. For me, to switch x and y and solve it. But I'm pretty good at math, right? If you struggle with solving, you might want to just go point by point and draw it, right? Okay. All right. Number 8, and I'll be done, all right? Let's do number 8, and I'll be done. Okay. So, again, here's the way I'm going to do it. F of x and y are the same thing, right? Switch x equals 3y minus 1, okay? Well, you guys can't see that. I'm sorry. Price at your job. Make sure okay, yeah, you and Ben. Well, Ben, you got to do your job then, right? Plus 1, x plus 1 equals 3y. Divide by 3. Divide by 3. So I'll get a 1/3 x plus 1/3. That's my inverse equation, okay? Now, again, if you have a hard time doing it this way, let's graph them. I'm going to graph them over here, okay? Just because I'm running out of room. So, if solving it is not your thing, you can do it point by point, right? How do you do it point by point? Well, first graph starts at negative 1, up 1, 2, 3 over 1. Am I going too fast? Let me slow down for a second. Okay. Okay. Here's my y equals. Now, you can switch point by point, right? This is a point at negative 1, 1, 2, 3, 4. This is a point at 0, negative 1. This is a point at 1, 2, and this is a point at 2, 5, okay? So again, if you have a hard time solving for y, or solving for x, then we can do it point by point. So let's see, point by point. If I switch this over to 0, 1 to negative 1, 0, I'd have a point right here. If I have a point at negative 1, 4, I'd go 4, negative 1. I'd go 1, 2, 3, 4, negative 1, right? Have a point at 1, 2, it'd become a 2, 1. Uh-oh, I'm off by 1. Which one did I goof up on? 0, negative 1 would be negative 1, 0. Which one am I goofed up on? I made a mistake. 4. Negative 1. Negative 1, 4 I'm off on. There we go. There we go. Now it's starting to line up, okay. 2, 5 becomes 5, 2. I am... 1, 2, 3, 4, 5. 1, 2. There we go. 4, negative 1. 1, 2, 3, 4, negative 1. I got that one. 0, negative 1 becomes negative 1, 0. Oh, that's why. That's why. Negative 1, 0. Okay, so here is my inverse. I must have made a mistake somewhere around there. All right. Last thing and I'm done, okay? Very last thing. Honest. Okay? Okay, watch me draw a line. Okay, I want you to watch this line right here. Okay? Last thing I'm done. Let me draw this line here. Alright? Last thing I'm done. So, you ready? We're going to barbecue, right?
Yes.
Right, Brian? We're barbecuing. We've got the skewer right here. Here's our skewer. We're going to rotate. We're going to rotate. We're going to rotate. Would this line rotate onto the pink line? Can you visually see that? Okay, we're going to rotate. We're going to barbecue. We're going to rotate. Would this line rotate on this line? Yeah. Hold on, Luke. Hold on, Luke. So, take a look at this line. Okay? Would this line rotate onto this line? Yeah. So what we're going to find about inverses, last thing, this is the line y equals x. This line y equals x. Every single point will be a reflection over that line for its inverse. Every single point is a reflection over that line, the inverse, okay? Where's my first sets of notes? Okay, here we go. Let me draw it in here, okay? Right there, boom. Every single point is a reflection over this line. Do you see it? And that's how inverses always work, okay? All right, so if you want to play around with, let me stop recording. Stop recording, Urge.